April 18th, 1943, 7:43 a.m. local time. The skies above Bougainville Island, Solomon Islands. Captain Takeshi Morioka, a veteran pilot of the Imperial Japanese Navy, with 17 confirmed kills painted on his Mitsubishi A6M0, pulled back on his control stick and watched his altimeter climb past 22,000 feet. He was leading a formation of 6 Zeros, escorting Admiral Isoroku Yamamoto's transport aircraft, and his eyes constantly swept the horizon, searching for the American fighters he knew would come. When he spotted them, 2 silver cruciform shapes diving from 25,000 feet, their twin booms and central nacelles unmistakable, he felt not fear, but anticipation. The P-38. He had heard the reports, read the intelligence summaries, listened to the whispered conversations in the officers' mess. But Morioka was confident. He banked hard left, calling out positions to his wingmen, and pushed his throttle forward. He would climb to meet them, gain the altitude advantage his Zero was famous for, and then dive on them with the sun at his back. It was the same tactic that had worked against the Wildcats, the Airacobras, the Warhawks. The metallic clang of his canopy lock echoed through the cockpit as he secured it, and he began his climb, watching the 2 American fighters grow larger in his windscreen. But something was wrong. The P-38 seconds weren't slowing down. They weren't struggling. They were accelerating in their dive, closing the distance faster than seemed possible. And when they pulled up, when they should have bled energy and become vulnerable, they didn't. They climbed. They climbed faster than his Zero. They climbed at an angle that defied everything he knew about aerial combat. Morioka's mouth went dry. He pushed his throttle to the firewall, feeling his engine scream in protest. But the gap widened. The P-38 seconds pulled away vertically, climbing into the sun, and then they were gone, repositioning for another attack with an ease that made his years of training feel suddenly obsolete. What Captain Morioka didn't understand, as he frantically scanned the sky for an enemy that had simply outclimbed him into invisibility, was that he wasn't fighting another airplane. He was fighting an industrial paradigm, a manifestation of American engineering philosophy that had transformed the very mathematics of aerial combat. The P-38 Lightning wasn't just superior to the Zero, it was superior in ways that couldn't be overcome by pilot skill, tactical innovation, or fighting spirit. This wasn't a contest between machines. It was a revelation of 2 fundamentally different approaches to war itself. The Japanese had built an aircraft around the concept of the pilot as the weapon, creating a lightweight, maneuverable platform that required exceptional skill to maximize. The Americans had built a weapon that happened to carry a pilot, a flying gun platform powered by 3,000 horsepower and carrying enough firepower to destroy a light cruiser. What Morioka experienced that morning wasn't defeat, not yet. It was the first tremor of a realization that would echo through every Japanese fighter squadron in the Pacific. They were bringing katanas to a gun factory. The specifications themselves told a story that Japanese intelligence officers struggled to believe, checking and rechecking their captured documents and interrogation reports, because the numbers seemed impossible. The Lockheed P-38 Lightning, entering service in late 1941 and reaching the Pacific Theater in significant numbers by 1942, was powered by 2 Allison V-1710 engines, each producing 1,475 horsepower, for a total of 2,950 horsepower. The Zero, by contrast, relied on a single Nakajima NK-1C Sakai engine, producing 940 horsepower. This wasn't a modest advantage. It was a gulf of power so vast that it fundamentally altered every aspect of flight performance. The P-38 could reach 414 miles per hour at 25,000 feet, not in a desperate dive, but in level flight, cruising at a speed that the Zero couldn't achieve, even pointing straight down with its engine screaming. The Zero's maximum speed was 331 miles per hour at 16,000 feet, and that was only achievable for brief periods before engine stress became dangerous. When American pilots reported that Japanese fighters couldn't catch us even if we flew straight and level, they weren't boasting, they were describing physics. The P-38 could simply fly away from any engagement, and there was nothing Japanese pilots could do about it. They could be more skilled, more aggressive, more willing to die, it didn't matter. the Lightning would accelerate into the distance, and pursuit was mathematical impossibility dressed in frustration. But speed was only the beginning of the avalanche, the first statistical blow in a cascade of overwhelming superiority. The P-38's rate of climb, the metric that truly defined air superiority in the vertical battlefield of World War II, was 2,850 feet per minute at sea level, increasing to 3,400 feet per minute at optimal altitude with later models. The Zero could manage 2,580 feet per minute at sea level, and that figure dropped precipitously as altitude increased due to its low-powered engine. This meant that in any engagement, the P-38 could choose the terms of combat. If a Japanese pilot managed to position himself advantageously, the Lightning could simply climb out of danger faster than the Zero could follow. If the P-38 pilot wanted to attack, he could dive from superior altitude, make a single devastating pass with his concentrated nose-mounted armament, and then climb back to safety before the Japanese pilot could even react. American tactical doctrine for the P-38 explicitly stated, "Never turn with a Zero. Dive, shoot, climb away." It wasn't caution, it was recognition that they possessed a three-dimensional superiority that made traditional dogfighting obsolete. Japanese pilots, trained in the art of the turning fight, the close-in knife fight where skill and courage determined victory, found themselves in a war where the enemy refused to fight on their terms, where every engagement became an exercise in frustration, as the silver twin-boomed aircraft attacked and retreated, at will, untouchable, unstoppable. The armament disparity compounded the psychological impact of the performance gap. The P-38 carried 4 Browning M2, 50 caliber machine guns, and 1 Hispano-Suiza, 20mm autocannon, all mounted in the nose, all firing through the propeller arc without synchronization issues, all converging at a single point, 300 yards ahead of the aircraft. This meant that every round, every single bullet and cannon shell traveled on precisely the same trajectory. There was no spread, no need to calculate convergence, no complexity. When a P-38 pilot put his target in his gun sight and pulled the trigger, 3,400 rounds per minute of combined firepower traveled along parallel paths directly at that target. The effect was devastating. Pilots described Japanese aircraft exploding when hit, disintegrating under the concentrated barrage. One burst, often lasting less than 2 seconds, was enough to destroy any Japanese fighter. By contrast, the Zero carried 2 7.7mm machine guns in the nose and 2 20mm cannons in the wings. The machine guns were too light to reliably damage American aircraft with their self-sealing fuel tanks and armor plate, and the wing-mounted cannons suffered from convergence issues. The guns were angled inward to meet at a specific distance, meaning they were only truly effective at that precise range. Get too close or too far, and much of the firepower missed entirely. Japanese pilots had to maneuver into the exact right position and maintain it long enough to score hits. American pilots just had to point and shoot. The production numbers transformed tactical superiority into strategic inevitability, revealing the true face of industrial warfare. Lockheed would eventually produce 10,037 P-38 Lightnings between 1,941 and 1,945. The Burbank, California factory operated 24 hours a day, 7 days a week, with 3 shifts of workers assembling aircraft on production lines that Henry Ford himself had helped design. At peak production in 1944, a new P-38 rolled off the assembly line every 45 minutes. Every hour, Lockheed produced more firepower than some nations possessed in their entire air forces. The Japanese, meanwhile, manufactured approximately 11,000 Zeros during the entire war, seemingly comparable until you examined the larger context. The Zero was Japan's primary fighter, serving in every theater, on every front, for the entire duration of the war. The P-38 was one of several advanced American fighters. The P-47 Thunderbolt would be produced in numbers exceeding 15,000, the P-51 Mustang in numbers exceeding 15,000, the F-6F Hellcat in numbers exceeding 12,000. The Americans weren't just outproducing Japan in single aircraft types, they were outproducing them across every category simultaneously. For every Zero that rolled off the Mitsubishi assembly line, 5 or 6 comparable or superior American fighters entered service. And when a Japanese pilot was shot down, if he survived and made it back to base, he might wait months for a replacement aircraft. When an American pilot was shot down, if he was rescued, he could be in a new P-38 within days, sometimes within hours. The range specifications told yet another story, one that Japanese commanders found almost more disturbing than the speed and climb advantages. The P-38, equipped with external drop tanks, could fly 1,300 miles on a single fuel load. This gave it a combat radius, the distance it could fly to a target, fight, and return to base of approximately 450 miles. The Zero, also equipped with drop tanks, could match or even exceed this range, which was one of its few competitive advantages. But the Americans used this range differently, in ways that revealed a fundamental difference in strategic thinking. The P-38 seconds based in Guadalcanal could reach Rabaul, 650 miles away, conduct combat operations, and return home. They could escort bombers deep into Japanese-held territory, providing protection for the entirety of the mission. They turned the vast Pacific, which Japanese planners had assumed would serve as a defensive buffer, an ocean too large for effective enemy air operations, into a highway for American air power. Japanese fighters, even with their impressive range, were increasingly forced into defensive roles, scrambling to intercept American raids and finding themselves outnumbered by escorts that could fight them at every altitude, outrun them in every direction, and still have enough fuel to make it home. The mathematics of attrition became devastating. A Japanese pilot might survive an engagement, might even score a kill, but if he was low on fuel and had to disengage to make it back to base, the P-38 seconds would simply reform and continue the mission. American pilots could fight, disengage to assess damage, and re-engage if conditions were favorable, all while maintaining enough fuel reserve to return to friendly territory. The tactical flexibility this provided was immeasurable. Lieutenant Hiroshi Nishizawa, one of Japan's most skilled pilots with over 80 confirmed kills, wrote in his diary after an engagement with P-38 seconds over Rabaul in October 1943. "We climb for altitude and they are already there. We dive to attack bombers and they dive faster. We try to escape and they run us down like we are standing still. I shot one today, my wingman and I worked together perfectly. Caught him in a scissors maneuver, and I put a full burst into his wing root. I saw the hits, saw the metal tearing. He didn't even seem to notice. He just firewalled his throttles and climbed away. We pushed our engines to failure point trying to follow, and he disappeared into the clouds above us, going vertical, while my Zero shuddered on the edge of a stall. My mechanics found nothing wrong with my aircraft after landing. It was performing perfectly. That's what scares me. I did everything right, and it meant nothing." This was from one of Japan's best pilots, a man who had survived years of combat, who had mastered every tactical nuance of his aircraft, and his testimony was a glimpse into the despair spreading through Japanese fighter squadrons. Skill couldn't overcome the gap, experience couldn't bridge it. Courage was irrelevant when the enemy could simply leave the battlefield at will. The technological sophistication embedded in the P-38 extended beyond the obvious performance metrics into systems and features that Japanese engineers couldn't replicate, even if they had captured an intact example. The Lightning's turbochargers, massive General Electric systems weighing over 200 pounds each, allowed its Allison engines to maintain full power at altitudes where Japanese engines gasped for oxygen. At 25,000 feet, where the Zero's Sakai engine was producing perhaps 60% of its rated horsepower, the P-38's Allisons were still generating nearly full power, breathing easily through their superchargers and intercoolers. This translated to combat performance that seemed to violate the laws of physics to Japanese pilots who watched P-38 seconds accelerate at altitudes where their own aircraft could barely maintain level flight. The Lightning's counter-rotating propellers eliminated the torque effect that made most fighters veer left on takeoff and complicated high-speed maneuvers, giving it stability that felt almost artificial to pilots transitioning from conventional aircraft. Its tricycle landing gear, revolutionary at the time, made ground handling easier, reduced accident rates, and allowed for shorter takeoff distances. Every aspect of the design reflected an engineering philosophy that valued capability over simplicity, that accepted weight and complexity in exchange for performance advantages that could be measured and quantified. The defensive systems on the P-38 highlighted another crushing disparity. The aircraft featured self-sealing fuel tanks, a technology that used multiple layers of rubber that would swell and close when punctured, preventing fuel leakage and dramatically reducing fire risk. Japanese aircraft had no equivalent system until very late in the war, and even then, it was implemented poorly. A Zero that took even a handful of rounds into its fuel tanks would leak gasoline, often igniting from tracer rounds or engine heat. American pilots called them flying Zippos because they burned so readily. The P-38 also featured armor-plating heavy steel plates behind the pilot's seat, armored glass in the windscreen, additional armor protecting the engines and cooling systems. This armor added hundreds of pounds to the aircraft's weight, but it meant that P-38 pilots regularly returned to base with battle damage that would have killed a Japanese pilot outright. There are documented cases of P-38 seconds returning with one engine shot out, dozens of hits to the airframe, hydraulic systems destroyed, and still making successful emergency landings. The pilot would climb out, assess the damage, fill out the report, and be flying a replacement aircraft the next day. Japanese pilots had no such luxury. Any significant hit often meant death, and if they survived to bail out over water, rescue was uncertain at best. The psychological impact of this disparity cannot be overstated. American pilots knew they had a reasonable chance of surviving being shot down. Japanese pilots knew that any hit might be their last, that their aircraft offered no forgiveness, no margin for error. The tactical flexibility of the P-38 extended into roles that single-engine fighters couldn't effectively fill, making it not just a superior fighter, but a multi-role asset that multiplied American air power effectiveness. The Lightning served as a long-range escort fighter, a fighter bomber carrying up to 4,000 pounds of bombs or rockets, a reconnaissance platform with cameras mounted in the nose, a night fighter equipped with radar, and even a Pathfinder aircraft leading bomber formations. The same basic airframe could be adapted to numerous missions, and often was a single P-38 unit might fly fighter sweeps in the morning, bomber escort in the afternoon, and ground attack missions at dusk. This operational flexibility meant that American commanders could concentrate and adapt their forces in ways that Japanese planners couldn't match. A Japanese fighter unit flew fighters, period. They had one mission, one set of tactics, one narrow band of optimal performance. American P-38 units could respond to whatever the tactical situation demanded, and this adaptability, this ability to present the enemy with multiple problems simultaneously, was itself a form of superiority. Japanese defenders never knew if the P-38 seconds they spotted were screening for bombers, preparing to strafe, or simply hunting for targets of opportunity. Every contact required a full response, and Japan's shrinking pilot pool and fuel reserves couldn't sustain that level of constant vigilance. The accounts from Japanese pilots who survived encounters with P-38 seconds reveal a progression from confidence to confusion to something approaching despair. Early war reports from 1942 described the Lightning as another American fighter, heavy and fast but manageable. By mid-1943, the tone had shifted dramatically. Intelligence reports compiled from pilot debriefings used terms like impossible to catch, overwhelming firepower, and unbeatable in vertical combat. By 1944, pilots were filing reports that essentially gave up on engaging P-38 seconds, except under ideal circumstances, when they had overwhelming numerical superiority and the advantage of surprise. Even then, success rates were dismal. Analysis of combat records shows that P-38 seconds in the Pacific Theater achieved a kill ratio of approximately 5-1 against Japanese fighters. For every Lightning lost in air combat, 5 Japanese aircraft were destroyed, and this ratio understates the impact because it only counts direct combat losses. It doesn't account for Japanese aircraft lost to accidents while trying to intercept P-38 seconds at altitudes their engines couldn't handle. pilots who stalled out trying to climb after lightnings and crashed, or aircraft that suffered engine failures from being overstressed in hopeless pursuits. The indirect attrition, the wear and tear on men and machines from constantly fighting a superior enemy, was itself a strategic victory for the Americans. The mythology surrounding Japanese fighter design began to crumble when captured Zeros were tested by American engineers at the Naval Air Station in San Diego. The results were systematically disseminated through intelligence channels, and what they revealed was a fighter designed around a philosophy that no longer matched the reality of industrial warfare. The Zero was a masterpiece of weight reduction, stripping away everything inessential to create an aircraft that could outturn anything in the sky. But inessential included pilot armor, self-sealing fuel tanks, radio equipment, and structural redundancy. The Americans measured the Zero's aluminum skin at certain points and found it thinner than the aluminum foil in a cigarette pack. The airframe flexed visibly under stress. One engineering report noted that the Zero is less an aircraft than an optimization problem solved by removing everything related to survivability. This wasn't a criticism of Japanese engineering skill. The designers had created exactly what their requirements demanded. But those requirements assumed a type of warfare that was vanishing even as the aircraft entered service. The Zero was designed for short-range combat over China, for engagements where the superior pilot would always win, for a war where individual skill mattered more than industrial capacity. The P-38 was designed for a different war entirely, one where the pilot was a system operator, where the aircraft itself was the weapon, and where victory went to whoever could build the most capable machines the fastest. The psychological dimension of facing an invincible enemy manifested in ways that Japanese commanders documented with increasing alarm. Pilots began reporting physical symptoms before missions when P-38 seconds were expected: nausea, shaking hands, stress-induced illness. Squadron readiness rates dropped not because of mechanical issues, but because pilots were increasingly reluctant to fly against the American fighters. This wasn't cowardice, it was rational fear. Japanese pilots were experiencing what modern psychologists would recognize as learned helplessness, the understanding that no matter what actions they took, no matter how skilled or brave they were, the outcome was predetermined. Flight instructors at Japanese training schools tried to maintain morale by teaching advanced tactics specifically designed to counter the P-38's advantages, but these tactics invariably required perfect execution, numerical superiority, and significant altitude advantage to have any chance of success. In practice, Japanese pilots rarely had any of those conditions in their favor. American forces controlled when and where engagements occurred, operated from the altitude band of their choosing, and could always disengage if conditions weren't favorable. The veteran pilots who survived into 1944 developed a sort of fatalistic pragmatism. They would follow orders, they would engage the enemy, but they held no illusions about their chances of survival. They were buying time with their lives, and they knew it. The industrial capacity gap that manifested in aircraft production extended into every aspect of the air war, creating compounding advantages that transformed tactical superiority into strategic dominance. When a P-38 was damaged in combat, it flew back to a base where spare parts were abundant, where trained mechanics had diagnostic equipment and repair manuals, where entire assemblies could be replaced, rather than jury-rigged. Japanese maintenance crews were performing miracles with limited resources, cannibalizing multiple damaged aircraft to create one functional airframe, fabricating replacement parts by hand when supply chains failed, running engines hundreds of hours beyond their design limits because no replacements were available. This meant that even when Japanese aircraft were theoretically competitive on paper, in practice they were operating in degraded conditions, worn engines, patched airframes, guns that jammed more frequently because replacement springs and firing pins weren't available. The Americans could afford to be wasteful, discarding components that were merely worn rather than waiting for complete failure. They could rotate aircraft out of service for major overhauls on regular schedules. They had the luxury of reliability because they had the industrial capacity to ensure it. Japanese crews were performing emergency maintenance between every mission, and even then, mechanical failures were climbing steadily as the war progressed. The training pipeline differential created a widening skill gap that compounded all other disadvantages. American pilots in 1943 to 44 were receiving 300 to 400 hours of flight training before entering combat, with specialized training in instrument flying, gunnery, formation tactics, and advanced combat maneuvers. They were learning in the same type of aircraft. They would fly in combat, building muscle memory and confidence. When they reached operational squadrons, they were assigned as wingmen to experienced pilots for their first dozen missions, easing into combat gradually. Japanese training programs, always abbreviated compared to American standards, were collapsing entirely by 1944. Pilot candidates were receiving 100 to 150 hours of flight training, often in obsolete aircraft that handled nothing like the fighters they'd eventually fly. They were learning tactics that no longer worked because veteran pilots who might have updated the curriculum were dead. When they reached operational units, they were often thrown into combat immediately because squadrons were so desperate for replacement pilots. The predictable result was catastrophic loss rates among new pilots. Some Japanese squadrons in late 1944 were losing 50% of their replacement pilots in their first 3 missions. These weren't pilots being outfought. They were pilots who hadn't been adequately trained to survive in a modern air combat environment, facing an enemy who had every advantage in equipment and preparation. The Americans were creating a professional pilot corps. The Japanese were feeding barely trained teenagers into a meat grinder and calling it an air force. The specific tactical scenarios that played out in the skies above the Pacific became tragically predictable, each one a small-scale demonstration of the larger disparity. A typical engagement in 1943 might unfold like this. Japanese controllers would detect an American raid bombers, escorted by P-38 seconds, approaching at 22,000 feet. They would scramble everything available, knowing that allowing the bombers through meant destroyed supply dumps, damaged airfields, or sunken transports. The Japanese fighters would claw for altitude, their engines straining, reaching perhaps 20,000 feet by the time the Americans arrived. The P-38 seconds, operating at their optimal altitude, would be circling overhead at 27,000 feet, waiting. When the Japanese fighters committed to their attack on the bombers, diving to build speed, the P-38 seconds would pounce. They would dive from above, accelerating to speeds exceeding 450 miles per hour, make a single high-speed pass through the Japanese formation, with all guns firing, and then this was the killing part. They would zoom, climb back to altitude, faster than the Japanese fighters could follow. The Japanese pilots would watch the P-38 seconds extend away vertically, untouchable, knowing they would be back in 30 seconds for another pass. Meanwhile, other P-38 seconds would engage any Japanese fighters that tried to pursue, scissoring and using their superior speed to always maintain the energy advantage. The bombers would complete their run, often with minimal interference, because the escorts had suppressed the defenders so effectively. And then the entire American formation would leave, flying away at 300 miles per hour at 25,000 feet, while the Japanese fighters desperately tried to organize a pursuit they knew was futile. This wasn't combat. It was systematic dismantling. The evolution of American tactics specifically tailored to the P-38's advantages demonstrated how quickly the learning curve could be applied when backed by superior equipment and training infrastructure. Early P-38 units in the Pacific had tried to dogfight with Japanese fighters, with mixed results. The Lightning could turn reasonably well for a large aircraft, but it couldn't match the Zero's legendary maneuverability. These initial engagements produced modest kill ratios and led to some American pilots expressing frustration with the aircraft. But the tactical development cycle was rapid and ruthless. After-action reports were compiled, analyzed, and incorporated into training doctrine within weeks. By late 1942, the standard tactics had crystallized: maintain altitude advantage, fight in the vertical plane, never turn with the enemy, use speed and climb rate to control engagement parameters. Units that adopted these tactics saw their kill ratios climb dramatically. By mid-1943, experienced P-38 units were achieving 10-to-1 kill ratios because they were fighting the aircraft's war, not the enemy's war. They were imposing their terms on every engagement, using their advantages systematically. And when Japanese pilots tried to adapt, trying to avoid engagement, trying to ambush from the sun, trying to force the Americans into turning fights, the P-38 seconds simply refused to cooperate. They would disengage, climb to safety, reposition, and attack again on their terms. The American pilots had the luxury of patience, because they had the capability to enforce their choices. The long-range missions that became the P-38's signature contribution to the Pacific War effort represented a revolution in air power projection that Japanese planners had never anticipated. The assassination of Admiral Yamamoto on the 18th of April, 1943, the same date that Captain Morioka experienced his first frustrating encounter with the Lightning, was a perfect illustration of this capability. American codebreakers intercepted Japanese communications detailing Yamamoto's inspection tour, including precise times and locations. The nearest American base capable of reaching him was at Henderson Field on Guadalcanal, 435 miles from the interception point over Bougainville. No other fighter in American inventory had the range and performance to make this mission possible. 16 P-38 seconds, loaded with external fuel tanks, flew a circuitous 435-mile route at wavetop height to avoid detection, arrived at the exact time and location specified in the intercepts, found Yamamoto's 2 transport aircraft escorted by 6 Zeros, and shot down both transports in a brief, violent engagement. The mission, known as Operation Vengeance, required 2.5 hours of precision navigation over open ocean, followed by a high-speed combat engagement, followed by another 2.5-hour return flight. Several of the P-38 seconds landed at Henderson with less than 50 gallons of fuel remaining in their tanks. Japanese commanders were stunned. They had assumed Yamamoto would be safe because the Americans had no bases within range. They had underestimated not just the P-38's range, but the Americans' willingness to push that range to its absolute limit, the navigation precision made possible by American technology and training, and the ruthless intelligence apparatus that had decrypted their communications in the first place. The mission was a microcosm of the entire Pacific Air War: superior technology, superior training, superior intelligence, and the will to exploit all three to maximum effect. The escort missions that became routine by 1944 illustrated the cumulative impact of the P-38's capabilities in a different way. Heavy bombers, B-24 Liberators, primarily were conducting raids across vast swaths of the Pacific, hitting Japanese bases, shipping, and infrastructure. These missions were only possible because the P-38 seconds could escort them for their entire route, protecting them from interception. Japanese planners had to defend everywhere simultaneously because American bombers, escorted by Lightnings, could strike any target within a 600-mile radius, and defending everywhere meant defending nowhere effectively. Japanese fighter resources were spread thin, scrambled reactively rather than concentrated for maximum effect, and when they did manage to intercept a bombing raid, they faced not just the bombers' defensive guns, but also swarms of P-38 seconds that had the fuel to remain on station throughout the engagement. The mathematics of attrition were devastating. Every raid cost the Japanese aircraft they couldn't replace, and pilots they couldn't adequately train replacements for, while American losses, even when significant, were made good within days. The strategic bombing campaign in the Pacific, less famous than its European counterpart but equally destructive, was made possible by the P-38's unique combination of range, performance, and firepower. Without the Lightning, much of the Pacific would have remained beyond the effective reach of American air power until the very end of the war. The photo-reconnaissance variants of the P-38 demonstrated yet another dimension of American technological and doctrinal sophistication. The F-4 and F-5 variants had their guns removed and cameras installed in the nose, creating reconnaissance platforms that could penetrate deep into Japanese-held territory, photograph targets from high altitude, and escape before Japanese fighters could intercept. These unarmed aircraft relied entirely on speed and altitude for survival, and they were phenomenally successful. Japanese commanders would sometimes receive intelligence reports about American reconnaissance P-38 seconds that had photographed their bases from 30,000 feet, and there was nothing they could do about it. No Japanese fighter could reach that altitude with enough performance remaining to intercept a P-38 at full speed. The reconnaissance Lightnings mapped every Japanese installation in the Pacific, providing bomb damage assessment, tracking ship movements, identifying supply concentrations, and building the intelligence picture that made American operations so devastatingly effective. The Japanese had reconnaissance aircraft too, but they operated at lower altitudes, were vulnerable to interception, and often failed to return. The Americans could conduct reconnaissance almost with impunity, adding another layer of information advantage to their already overwhelming material superiority. By late 1944, the psychological impact of the P-38's dominance had become a weapon in itself, one that Japanese commanders struggled to counter. There are documented cases of Japanese fighter units refusing missions when they learned P-38 seconds were involved. Not refusing explicitly, that would have been insubordination, potentially punishable by death, but finding reasons why the aircraft weren't ready, why the weather was unsuitable, why the tactical situation made success unlikely. Squadron commanders found themselves having to personally lead missions to shame their pilots into participating. The warrior culture that had been Japan's assumed advantage, the willingness to die for the emperor, the emphasis on spirit over material, was breaking down in the face of an enemy that had rendered individual courage irrelevant. You couldn't outspirit a 3,000 horsepower engine. You couldn't Bushido your way through 50 caliber armor-piercing rounds. Japanese propaganda continuously emphasized fighting spirit, the superiority of the Japanese warrior, the inevitable victory that would come from moral strength. But the pilots who faced P-38 seconds knew the truth: they were being sacrificed not to win, but to slow an inevitable defeat. Some continued fighting with incredible bravery because they had no choice, because their culture provided no framework for honorable surrender, because dying in combat was preferable to the shame of survival. But the certainty was gone. The assumption that skill and courage could overcome any obstacle had been systematically demolished by American aircraft that were simply, measurably, undeniably better. The maintenance requirements of the P-38 revealed another subtle but significant advantage in the form of operational readiness rates. The Lightning was a complex aircraft: 2 engines, 2 turbochargers, hydraulic systems for landing gear and flaps, complex fuel management, trim systems to handle asymmetric thrust, and more. On paper, this complexity should have led to lower readiness rates compared to simpler aircraft. In practice, the opposite occurred. American squadrons regularly maintained operational readiness rates of 85% for their P-38 seconds, meaning that on any given day, 3/4 or more of their aircraft were capable of flying combat missions. This was possible because of the robust supply chain, the availability of trained mechanics, the comprehensive maintenance manuals, and the engineering that had designed in redundancy and accessibility. Japanese squadrons, flying mechanically simpler aircraft, were achieving readiness rates of 50–60% by 1944, and those numbers were declining. The zero might have been easier to maintain in theory, but in the resource-starved environment of the Japanese military, theory meant nothing. The P-38's complexity was an advantage because it was complexity backed by the industrial capacity to support it. Every system had a backup. Every critical component had a spare readily available. Every problem had a documented solution. The Lightning was maintainable not because it was simple, but because it existed within an ecosystem designed to keep it flying. The accounts from American pilots provide a counterpoint to the Japanese experience, not triumphalist narratives, but matter-of-fact descriptions of capability advantage that bordered on boring. One P-38 pilot, interviewed after the war, described his standard combat engagement. "We'd see them climbing toward us. I'd push the throttles forward and we'd dive, not even a steep dive, maybe 30 degrees. We'd accelerate through 400 miles per hour, and by the time we reached their altitude, we were going so fast that we were through their formation before they could react. I'd pick a target, put the pipper on him, press the trigger for maybe 2 seconds, and he'd come apart. Then I'd pull up into a climb, and they couldn't follow. We'd reform at altitude and either go home or set up another pass if we still had ammunition. It wasn't exciting. It was clinical. That word clinical appears repeatedly in American accounts. The P-38 had removed the element of chance from fighter combat, transforming it from a contest of skill into a systematic process of destruction. Japanese pilots might be better trained in pure flight mechanics, might have better spatial awareness, might have more experience with close-in maneuvering. It didn't matter. The P-38 pilot could impose his will on the engagement because his aircraft gave him the tools to control every variable. He could choose when to fight, choose when to disengage, choose his altitude, his speed, his angle of attack, all with the knowledge that the enemy couldn't prevent any of those choices. The night fighter variants of the P-38 extended American dominance into hours that had previously offered Japanese forces some measure of safety. The P-38M, equipped with AN divided by APS-6 radar, mounted in an external pod, could detect and intercept Japanese aircraft in complete darkness. Japanese night operations critical for supplying beleaguered garrisons and evacuating wounded became increasingly perilous as American night fighters prowled the skies. The Japanese had no effective night fighter capability. Their aircraft lacked the speed and radar equipment necessary to operate effectively in darkness. This meant that American air superiority, already overwhelming during daylight hours, extended to 24-hour coverage in critical areas. Japanese commanders couldn't even use darkness as a refuge, couldn't schedule supply missions for the safety of night, couldn't exploit the natural cover that darkness should have provided. The Americans had technologically overcome even the day-night cycle, adding another layer of relentless pressure that steadily ground down Japanese capabilities. Every hour of every day, in every weather condition, the P-38 seconds could find them, could intercept them, could kill them. The development of improved versions of the P-38 throughout the war demonstrated American industrial and engineering capacity in action. The P-38 Jules, introduced in 1943, addressed the only significant weakness: the Lightning had compressibility issues in high-speed dives. Dive flaps were added under the wings, allowing pilots to safely dive at speeds that would have caused control problems in earlier models. This modification took a good fighter and removed its single tactical limitation, creating an aircraft that had no weaknesses Japanese pilots could exploit. The P-38 Liters, the final and most produced variant, featured 1,600 horsepower engines, improved avionics, stronger airframe, and additional hardpoints for bombs and rockets. Each iteration was better than the last, and the improvements came steadily, relentlessly, without disrupting the production pipeline or creating supply chain chaos. Japanese aircraft development, by contrast, was increasingly chaotic. The Zero received minimal updates throughout most of the war, and when improved fighters like the Raiden, Shiden, and Ki-84 were developed, production was delayed by material shortages, sabotage by Allied intelligence, and strategic bombing of factories. The few advanced Japanese fighters that reached operational service in significant numbers came too late, and in numbers too small to matter. The Americans could improve their aircraft while maintaining massive production volumes. The Japanese could do neither. The strategic bombing of Japanese aviation industry in 1944-45 revealed the final layer of overwhelming advantage. American forces could destroy the enemy's ability to produce aircraft while maintaining and expanding their own production. B-29 superfortresses, often escorted by P-38 seconds on portions of their routes, systematically destroyed Japanese aircraft factories, engine plants, and aluminum production facilities. Each raid reduced Japanese output, and the cumulative effect was catastrophic. Japanese aircraft production, which had peaked at about 2,500 aircraft monthly in mid-1944, dropped to a few hundred per month by early 1945. And those aircraft that were produced were often hidden in dispersed facilities to protect them from further bombing, making delivery to operational units difficult or impossible. Meanwhile, American production continued to accelerate by 1945. The United States was producing over 9,000 military aircraft monthly across all types. The Japanese weren't just losing the war in the present, their capacity to fight in the future was being systematically eliminated. The P-38 seconds that protected those bombers, that maintained air superiority over Japanese skies, were enabling the destruction of the very industrial base that might have produced aircraft capable of challenging them. It was a self-reinforcing cycle of dominance. The testimony from Lieutenant Commander Saburo Sakai, one of Japan's most famous aces who survived the war and wrote extensively about his experiences, provides perhaps the most authoritative Japanese perspective on the P-38's impact. In his memoirs, translated and published after the war, Sakai devoted significant attention to the Lightning. The P-38 was the aircraft that taught us we could not win. Not that we had lost that came later, with the other American fighters and bombers, but that victory was impossible. Every encounter with the Lightning was a lesson in mathematics. We could calculate the speed difference, the rate of climb difference, the firepower difference, and once you did the mathematics, you understood that only luck or significant American error could save you. Japanese pilots are trained to never give up, to fight to the death if necessary, to believe that spirit can overcome material disadvantages. But the P-38 stripped away those beliefs with the brutal honesty of numbers. When you watch an enemy climb away from you vertically, when you have your throttle at maximum and you're falling behind, when you fire your guns and see your rounds falling short while his bullets are tearing your wing apart, you understand that you are not fighting a pilot. You are fighting an industrial system, and you cannot defeat a system with courage. The oil crisis that progressively strangled Japanese military operations from 1944 onward created a perverse situation where Japanese fighters, even if available, even if pilots existed, often couldn't fly because fuel wasn't available. The American submarine campaign had severed the sea lanes between the Dutch East Indies and Japan, cutting off the primary source of petroleum. By late 1944, Japanese fighter units were rationing fuel, limiting training flights, choosing which defensive missions to fly based on fuel availability rather than strategic necessity. P-38 units had no such concerns. Fuel flowed freely from American tankers, stored in abundance at every base, available whenever needed. This meant that even in the rare situations where Japanese fighters might have had a tactical advantage defending their home islands, operating over familiar terrain, concentrating forces for a decisive battle, they often couldn't fully engage because fuel limitations prevented full squadron deployments. American pilots flew multiple missions per day if required. Japanese pilots might fly one mission per week, conserving their aircraft and their fuel for critical situations that never came. The disparity had moved beyond technology into basic logistics, and Japan was losing that battle even more comprehensively than they were losing in the air. The accounts of the end of the war are particularly poignant when viewed through the lens of Japanese fighter operations. By the spring of 1945, organized Japanese air defense had essentially collapsed. P-38 seconds flew over the Japanese home islands with relative impunity, their pilots finding fewer and fewer targets, often completing missions without seeing any enemy aircraft at all. The few Japanese fighters that did intercept were often flown by barely trained pilots in obsolete aircraft, making desperate, often suicidal attacks that accomplished little beyond adding another name to the casualty lists. American pilots described it as sad or depressing rather than triumphant. They were killing enemies who had no chance, in aircraft that couldn't compete, in a war that was already decided. The P-38 pilots who had fought experienced Japanese aviators in 1943, the ones who had outturned, outmaneuvered, and outthought them, making every mission a challenge that required skill and caution, found themselves, in 1945, flying missions against opponents who seemed to be participating in a different war entirely. The veteran Japanese pilots were dead, the good aircraft were destroyed or grounded for lack of fuel, and what remained was a hollow shell of what had once been a formidable air force. The P-38 hadn't just defeated Japanese fighters, it had participated in their destruction so thoroughly that by the war's end, they had ceased to exist as an effective force. The examination of captured Japanese documents after the war provided the final crushing statistical confirmation of what pilots on both sides had experienced. Japanese military records showed that, in theaters where P-38 seconds operated extensively, primarily the Pacific, and later in the Mediterranean, Japanese loss rates were 40–60% higher than in theaters where they faced other Allied fighters. This wasn't because American pilots in P-38 units were more skilled, it was because the aircraft itself was simply more lethal. The specifications allowed tactics that worked reliably and repeatedly. A mediocre P-38 pilot flying by the book tactics could defeat a good Japanese pilot in a Zero because the book was written around an aircraft that had overwhelming advantages. The best Japanese pilots, the ones who survived into late war through a combination of skill, experience, and luck, developed tactics that could occasionally exploit the P-38's few weaknesses, could occasionally score kills through perfect execution and aggressive maneuvering. But occasionally wasn't enough. The fundamental problem remained unsolvable. The P-38 could always dictate whether an engagement occurred, and in air combat, the ability to refuse unfavorable engagements was itself a form of invincibility. The economic analysis provides the final piece of the overwhelming evidence. The total cost to produce a P-38 Lightning in 1943 to 44 was approximately $120,000, including all labor, materials, and overhead costs. A Zero cost approximately $30,000 to produce in equivalent dollar terms. On the surface, this suggests the Zero was more cost-effective. You could build 4 Zeros for the price of one P-38. But this comparison is meaningless without context. The P-38, on average, survived 20 combat missions and achieved approximately 5 kills over its operational lifetime. The Zero, by mid-war, was averaging 3 combat missions before being lost, with less than 1 kill per aircraft. The cost per kill, the relevant economic metric, was approximately $24,000 per kill for the P-38 and $100,000 per kill for the Zero. The expensive American fighter was actually 4 times more cost-effective than the cheap Japanese fighter because it survived longer and killed more enemy aircraft per dollar invested. And this doesn't account for the value of the American pilots, with their extensive training, represented a significant investment that was protected by the P-38's armor and survivability. Japanese pilots, with their abbreviated training, represented a smaller investment that was squandered in aircraft that offered no protection. Every economic analysis, every efficiency calculation, every cost-benefit assessment pointed to the same conclusion. The American approach, despite its apparent wastefulness and complexity, was systematically more effective than the Japanese approach at every level of analysis. The doctrine and training materials developed by American forces, specifically for P-38 operations, codified the lessons learned into a systematic methodology for air combat that would influence fighter tactics for generations. The emphasis on energy management, maintaining speed and altitude advantage became fundamental doctrine. The understanding that aircraft performance could be quantified, and those specifications translated into tactical advantages, revolutionized how air combat was understood and taught. Japanese tactical doctrine, based on maneuver, warfare, and pilot skill, wasn't wrong, it was obsolete. It had been rendered irrelevant by aircraft that changed the fundamental equations of aerial combat. The Americans were writing new equations, and those equations stated simply, superior capability, properly employed, defeats superior skill, not sometimes, not in special circumstances, always, given time and repetition. The P-38 was the physical manifestation of that principle, a flying lesson in what industrial warfare meant when prosecuted by a nation with the resources and willingness to pursue absolute technological superiority. The post-war interviews with surviving Japanese pilots, conducted by American historians and military analysts, revealed the psychological scars left by years of fighting an unwinnable war against superior equipment. Many veterans described feelings of betrayal, not by their comrades or commanders, but by their own leadership that had sent them into combat against an enemy that Japanese industry couldn't match and Japanese training couldn't overcome. They spoke of the crushing recognition, usually coming gradually over multiple engagements, that personal excellence was insufficient. One pilot described it as, fighting the ocean. You might win individual battles against individual waves, but the ocean was inexhaustible and inevitable. The Americans could replace every loss, could train new pilots to operational competency faster than Japan could kill them, could produce aircraft in numbers that made Japanese production seem medieval by comparison. And the aircraft they were producing, the P-38, the F-6F, the P-47, the P-51 were all superior to anything Japan could field in significant numbers. The psychological impact of this realization, the understanding that courage and skill had been rendered tactically irrelevant by industrial capacity, left a generation of pilots with a profound skepticism about military adventurism and technological competition that would shape post-war Japanese culture in unexpected ways. The story of the P-38 Lightning and its dominance over Japanese fighters in the Pacific War is not primarily a story about aircraft. It is a story about what happens when industrial capacity, technological sophistication, and systematic doctrine are aligned against an enemy that possesses none of those advantages in sufficient measure. The Japanese had built an air force around the philosophy that the pilot was the weapon, that individual skill and fighting spirit could overcome material disadvantages, that a warrior tradition centuries old would triumph over American industrial might. The Americans had built an air force around a different philosophy, that the aircraft was the weapon, that technological superiority properly exploited was invincible. That victory went not to the most courageous but to the most capable. The P-38 Lightning, with its twin booms and devastating firepower and overwhelming performance advantages, was the manifestation of that philosophy. Every engagement was a test of those competing philosophies, and every engagement provided the same answer. Industrial warfare cannot be defeated by individual excellence. Technological superiority, when the gap is wide enough, is absolute. 3,000 horsepower beats 900 horsepower every time, regardless of who is in the cockpit. The Lightning proved something that military strategists had theorized but never definitively demonstrated, that in modern warfare, the advantage lies overwhelmingly with the side that can produce superior equipment in overwhelming quantities while maintaining the logistical systems to keep that equipment operational. The P-38 wasn't invincible. Hundreds were shot down during the war, destroyed by Japanese fighters and ground fire and operational accidents. But it was systematically, reliably, predictably superior to everything it faced, and that systematic superiority compounded over time into strategic dominance. Japanese pilots weren't defeated because they lacked courage or skill. They were defeated because they were given an impossible task: overcome a 3-to-1 performance disadvantage with nothing but fighting spirit. Some managed it, occasionally, when circumstances aligned perfectly, but tactics that require perfect execution and ideal circumstances aren't tactics, they're prayers. And prayers don't win wars against enemies who can quantify every advantage, who can produce weapons designed to exploit every weakness, and who have the industrial capacity to replace losses faster than you can inflict them. The P-38 Lightning was the weapon that taught the Japanese Empire this lesson, at a cost measured in thousands of dead pilots and hundreds of destroyed aircraft, in the systematic dismantling of an air force, in the crushing realization that they were fighting a type of war their society wasn't organized to win. That lesson, written in fire and aluminum across the skies of the Pacific, stands as one of the clearest demonstrations in military history of what happens when warfare becomes industrial, when technological gaps become unbridgeable, and when the avalanche of American production and capability buries any hope of victory under sheer, incomprehensible, overwhelming material superiority.